We will now get the second eigenvector, which will correspond to lambda equals to -1. So 6 minus -1 minus 3 minus 4 4 minus 2 minus 1 minus 1 minus 3 and 6 minus 3 minus 4 minus 1. This is x1 x2 x3 equals to 0. So the result is 7 minus 3 minus 4 4 minus 1 minus 3 6 minus 3 minus 3. See, x1 x2 and x3 equals to 0. So our first equation is 7x1 minus 3x2 minus 4x3 equals to 0. This is our first equation. Our second is 4x1 minus x2 minus 3x3 equals to 0. Then our third equation is 6x1 minus 3x2 minus 3x3 equals to 0. We subtract equation 1 and equation 3, so 7x1 minus 3x2 is 4x3 minus 6x1 plus 3x2 plus 3x3. So x1, this cancels out, and minus x3 is 0. So x1 is equals to x3. Then we substitute this x3 to the first equation. So 7x1 minus 3x2 minus 4x1 equals to 0. So minus 2 plus 3x1 minus 3x2 equals to 0. 3x1 equals to 3x2, so x1 equals to x2. Now when x1 is equals to 1, we get the same result as x2 equals to 1, then x3 equals to 1. So our second eigenvector is this one, 1 1 1. We have an eigenvalue equals to 0, and the eigenvector is 1/2 1 0, and the eigenvalue of -1 has the eigenvector of 1 1 1. We now have to get the third eigenvector. So the third eigenvalue is the 1. So 6 minus 1 minus 1 minus 3 minus 4 and 4 minus 2 minus 1 minus 3 and 6 minus 3 minus 4 minus 1. x1 x2 x3 is equals to 0. So our first equation is the 5x1 minus 3x2 minus 4x3 to 0. This is our first equation, and our second is 4x1 minus 3x2 minus 4x3 equals to 0. This is our second, and our third is 6x1 minus 3x2 minus 5x3 equals to 0. So our third equation. Okay, so we subtract the equation 2 from equation 1, so we get this one, 5x1 minus 3x2 is 4x3 x3 equals 0 minus 4x1 plus 3x2 plus 3x3 equals 0. So we get this x1 minus x3 equals 0, then x1 equals to x3. We substitute x3 here in the first equation, so 5x3 minus 3x2 minus 4x3 equals to 0. So x3 minus 3x2 equals to 0. So x3 equals to 3x2. So x2 is 1/3 of x3. So when x3 equals 1, x2 equals 1/3. And since x1 equals x3, so x1 is also 1. So our third eigenvector is 1, 1/3, and 1. Now we have 3 eigenvalues and 3 eigenvectors. We then input this to the general solution, which is y equals to c1, the eigenvector, e to the eigenvalue times t, plus c2, the second eigenvector, e, the second eigenvalue times t, plus c3, the third eigenvector, times e to the power of the third eigenvalue. Our eigenvalues and eigenvectors here, so we have c1, the first eigenvalue, which is 1/2, 1 and 0, e to the, our first eigenvalue is 0, so then c2, our second eigenvector, which is 1, 1, 1, times e to the power of our second eigenvector, which is -1 t, and plus our c3, plus our c3 times the third eigenvector, which is 1, 1/3, 1, e to the power of 1t. So we simplify this equation. C 1/2, 1, 0, e to the 0 is 1, plus c2, 1, 1, 1, e minus t, plus c3, 1, 1/3, 1, e to the t. And this is our final answer. 1/2, 1, 0, plus c2, 1, 1, 1, e to the minus t, plus c3, 1, 1/3, 1, e to the t.